Welcome back. Today we'll see what is an algorithm. An algorithm is a step-by-step procedure or an instruction well defined for solving a specific problem. A well-designed algorithm can significantly impact the performance and efficiency of a program. But how do you measure the efficiency of an algorithm? This is measured using complexities. Complexities are again divided into two types: time complexity and space complexity. We have vast number of methods to measure the space as well as time complexity, but generally we use big O notation to measure the space as well as the time complexity. Big O notation is always considered as the worst or the maximum time or the space taken by an algorithm during computation process. Firstly, let's check the time complexity. Constant time complexity. This means that the execution time of an algorithm will always take the same amount of time regardless of the input. This is an example of an constant time complexity. Here the time taken by a function remains constant regardless of the input size. Next, linear time complexity. This means that the execution time of an algorithm will change linearly based on the input size. Let's consider an example below. Here we are printing an array value using a for loop. So here the time complexity will be n, which is length of the array. Quadratic time complexity. This means the execution time of an algorithm will change increases proportion to the square of the input. For this is an example of quadratic time complexity, which is nested for loops. Next, let's start with the logarithmic time complexity. Time complexity of a loop is considered as log n if the loop variables are divided or multiplied by a constant value. This is an example of the logarithmic time complexity. Let's see logarithmic time complexity, which is log of log n. Time complexity of a loop is considered as log of log n. So if the loop variables are reduced or increased exponentially by a constant. This is an example of logarithmic time complexity, which is log of log n. There are certain scenarios which are not covered here, but we'll cover this in the next videos. Now let's see how to calculate the time complexity with some examples. Let's consider this example. Here we have two for loops nested inside each other, one which will run for n times and other which will run for m times. Here the time complexity is m into n unless m equals to m. So if m is n, consider the other example. Here we have two for loops, but now we have parallel for loops instead of nesting them. So here the time complexity will considered as m plus n, but when m equals to n, the time complexity will be n. Now let's see the space complexity. Space complexity is measured how much memory an algorithm uses. We have a formula: space complexity equals to auxiliary space plus input space. Now let's see what is an auxiliary space. Auxiliary space is the additional space that an algorithm uses to store the temporary data. Complexity is considered as 1 if the space used by an algorithm does not change with respect to the input. Let's see an example. So the example could be accessing an element from an array. Linear space complexity n. The space complexity of a loop is considered as n if the space used by an algorithm is proportionate to the input. Let's see an example. Here in the example, we are creating a new array by copying each array element into a new array. Logarithmic space complexity. The logarithmic space complexity log n. Space complexity of a loop is considered as a log n if the space used by an algorithm is proportionate to the logarithm of the input. The example could be binary search. Exponential space complexity. The space complexity of a loop is considered as n square or n cube or n power c if the space of an algorithm is proportionate to the exponential of the input. Here the example could be Fibonacci search. Thank you for watching my videos. Please like, share and subscribe for more videos.